No.
Okay.
Do you
Hold
have
on.
another headphone jack?
I don't.
Let's try see if mine works, because this mine works. This phone is a bit trouble when I watch mine. Just plug it in.
Okay. Can you hear it?
Yes.
Okay, good. Here's Abby.
We're getting a little creative here.
Okay. I guess we can start.
Okay. All right. So 14 lesson 14. Number 1. So for number 1, I got the null hypothesis is all means are equal. The alternative hypothesis is one or more of the means differ from the others.
Yeah.
Yep.
Okay.
And then number 2, for one of the assumption of ANOVA, what is the rule for examining the standard deviation of each samples? So the rule is if the large standard deviation is not double the smallest standard deviation, then we will have the variance will be equal. Is that correct?
Yeah.
Okay.
Yeah.
Okay, so what are the differences between the test of hypothesis for ANOVA and the other tests of hypothesis that we have covered in this point of class? So I wasn't exactly sure how to answer this, but wouldn't it be based on the information that we got in earlier sections that we would have more than one mean?
Yeah, I think so.
Yeah, because it's like ANOVA, isn't it like calculating like several means together? Is that right?
Yeah.
And the other ones are just calculating either one or two means.
Yeah, that's what I got from it too. Okay, so part 2. Okay, I guess we didn't necessarily have to go over that. My bad. Design the study. So A, what's the research question? I said, does the age of death differ based upon the category of writing for an author? And then B, state null and alternative hypothesis. HO, all means are equal, and HA, one or more of the means differs from the other.
Yeah.
Okay, so 2, collect the data. Describe the data collected procedure. So, no, I didn't know it was collected though.
Yeah, they didn't say. So
They,
I just said I was unsure, but that they looked at the ages and the type of author.
Yeah.
you want to take 3?
Yeah. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. And so the gist of it was that we have a box plot, and it just goes, we have n in one column, the mean in another column, and then the standard deviation in another column. And then I can't remember what I put in the left column. The number of samples.
I think so.
Yeah, that's what I put. And then the total for n was 123, the mean was 70.36, and the standard deviation was 15.124. I'm not really exactly sure how they wanted a paragraph to summarize it. So I just did the graph.
Yeah, that's what I did.
Pretty much.
I always thought it was weird that they're like, write me an essay about this, and it's like, I don't know how to do that.
Yeah.
I'll do number 4, part A. What type of hypothesis test is appropriate, and then ANOVA tests, because there's several different means that are available.
Okay. What are the requirements for this test? So the 2 requirements that they list in the reading, though, The data are normally distributed for each group.
Mm-hmm.
Um, 1 second. For the first two groups, the sample size is greater than 30, so we can assume normality. Okay, so the requirement basically is that you need to make sure that the data are normally distributed for each group. And so to confirm that, you do the QQ plot to test their normality.
Yeah.
So the first group, I guess it's referring to this, is saying because the group is greater than 30, so we can assume that it's normal. But then the third group, because it's less than that, that you need to make a QQ plot to basically to make sure that if it's normal, and then you can test that by once you make the QQ plot a graph, if all the dots kind of line up together, then you kind of know.
Yeah.
And then also it also requires like for the variance to be equal for each group. And then you can check that by examining their standard deviation. If their standard deviations are close together, then the variance must be close together also. So the rule that they use is basically largest standard deviation is less than or equal to 2 times the smallest standard deviation. So then but on the answer key, they said that the variance for each group are equal. 17.297 is not equal. 13.052 are equal. I'm not sure what they mean by that. I don't know where they got.
I'm not completely sure.
1 second, let me look at. So the standard deviation for the second 0.297. And it is not double 13.05, so we assume that the variance are equal. Oh, so yeah, so the rule that they use to see if the variance is equal is if the largest standard deviation is less than or equal to 2 times the smallest. 2 times the smallest? So it's less than, so then we can assume that we're equal to. What do they mean by 2 times the smallest? Like,
so like the
2 times bigger?
So if it was double that number.
Yeah.
17 double? Yeah. Whoa, okay.
So if that was double, then 10 more.
Yeah. Are you guys still there?
Hey, sorry, my computer died of battery.
That's okay.
I'm really sorry. It's been a rough week. This stupid technology stuff. Okay, so where are we at now?
Okay, so
Okay.
let's scroll down. Okay, so
Yeah.
Okay.
okay, so for the F statistic, I got 6.563, and then E, the degrees of freedom, was 122.
So how did you get the F statistic?
I don't know right now, but so you do ANOVA, and then it has you select whatever it is that you select, and then you just compute that, and then one of the things they tell you is the F statistic.
Let me get into my. Did you do it through the SPSS?
Yeah.
It's kind of stupid. It takes forever.
So what is the ANOVA under then?
So when you go to analyze and compare means, and then
So
there's
where
the
do you
option
get
for
the
like,
data? Did we have to put in the data ourselves?
oh, it was one of the things that you download, I think.
It's for which group is this? I don't know. Oh, women's post.
Oh, that's what it was. So I'm like,
poet.
I don't remember seeing that at all. Okay, so women poets.
Mhm.
Yeah.
And so you said go to analyze.
Yeah, and then I think it's like compare means, and then
Compare means one way and another.
it's the last one under like the other T scores or
And
T
then did you use age or the type?
Age
Um,
for the dependent list, right?
yeah.
And then time for the what is the and then you click on optional and you select the descriptive and the main plot. And then you just obtain it and then it should pop up.
Oh, I have to put a factor in.
I'll click on that. Oh, okay. And then, yeah.
Oh, there we go. Okay. I was wondering about that. Okay. So I just go to analyze, go to compare the means, go to one-way ANOVA because that's what this is for. Then I'm going to put in what I'm trying to do as my dependent list, carry over what factor I'm trying to factor in there, make sure my options are selected descriptive and means plot, and that'll give me my proper one-way plot.
Yep.
Okay, cool. So for that, you said 120, correct?
122.
For the DF. Oh, 122.
Yeah.
Okay. Yeah.
Because you take the total, right? And then the
Just because it's within the group, it's the entire thing. Okay.
and then the p-value is it 0.002?
Yeah.
So then it's less than the alpha, which is 0.05. So then we reject the null hypothesis, right? Meaning that we don't have enough evidence, or we do have enough evidence.
So
I don't think we have enough evidence to
that's
accept
why
it.
002.
Oh, that's why we reject it, right? Because we don't.
Yeah.
And then for number 5, like, what significance can you conclude from that? I don't really know. I guess that poets die earlier. I have no idea what that would tell us, though. Unless they're trying to get us to think, like, I don't know, poets write more depressing things and then they die faster because they're depressed or something. I don't know.
The only thing I could think of is from other classes, not even related to biostatistics, is there's probably some other factor in connection of them being poets that makes it so that they're more likely to die earlier than novelists or nonfiction. Kind of how you're saying, like, probably depression or anxiety or something like that. So I guess if they're thinking of just like what other studies you would do, then probably something on finding out what kind of mental and physical problems are going on, that kind of thing.
Yeah.
And compare it to the novelists and nonfiction writers. But if they're looking for a particular number, then I have no idea what they're asking for.
Yeah. Alright.
So, yay, part 2.
Good.
Okay, so do you think we need to have SPSS open for this? I'm guessing so.
Probably. If you have to use it for the part 2, probably need it open for other one. So
Right. And then connect to that one.
Okay, so just to clarify, so when you reject the null, that means that we have enough evidence to say that the null hypothesis is not correct, right? That the alternative hypothesis is correct.
if the P is low, reject the null.
And then if we fail to reject it, that means that we don't have enough evidence to say that it's false. Okay.
Yes, because it would be greater than your null.
On the homework is like, I got so many wrong because I'm like, wait, what? Yes and no. Oh,
Well, it required if you got one question wrong, if you got that question wrong and you plugged it in for the next question, it made it that next question was correct.
so we're going to the group 14 group meeting quiz, right?
Yeah.
Okay. So, oh wait, is everybody there?
Not yet. I'm opening it because I went to the other desktop.
Oh, okay. Yeah, the other desktop is super slow.
Yeah.
Ridiculously slow.
Okay, I did it.
I might get splintered in my shirt.
All right.
On Saturdays, I can meet here.
Okay. Okay, you there, Liza?
Yeah.
Okay. So, number 3. In ANOVA hypothesis test, we reject the null. There is sufficient evidence to indicate at least one mean is different than the others.
Yes.
That would be true for sure.
Yeah.
Number 4, what requirements need to be checked when performing ANOVA hypothesis? Sample means are all positive. Data in each group are normally distributed. Variance are equal in each group. None in the above. So it's B and C.
Yeah, because the variance are equal in each group, and then normal distributed.
Yeah. Yep. Okay. Number 5. To check if each group is normally distributed, do the following. Construct a scatter plot, construct a histogram. It's the QQ plot.
Yeah.
Let's see.
We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The larger sample standard deviation is less than 2 times the small sample standard deviation. The larger sample mean is less than 2 times the smallest sample mean, and each group has the same sample size.
What would it be?
Yeah, it's the largest.
It's talking about standard deviation, not sample means.
Yeah.
Yeah.
And directly in the chapter it says if the largest standard deviation is less than or equal to 2 times the smallest standard deviation, then we will conclude that the variances are equal. So, yeah, so it would be D, the largest sample standard deviation is less than 2 times the smallest sample.
All right.
7. And the ANOVA hypothesis test is equivalent to conducting independent two-sample tests between every pair of samples. If there are 3 pairs, there are 3 pairs 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are 4 samples?
Let's check the complete pair of samples. If there are 3 samples, there are 3 pairs. 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are 4?
There's a 2 sample test in every what? ANOVA hypothesis test is equivalent to conducting 2 independent sample tests between every pair. If there are 3 samples, there are 3 pairs. How many samples are there? Would it be 4 pairs? Every pair.
I think it would be 6 pairs because
Or 4?
there'd be 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, and then 3 to 4.
Oh, is equivalent to conducting independent 2-sample p-test between every pair of samples. So there's 2 samples per pair of samples.
Right.
So there are 3 pairs, so there's technically 6 tests, but 3 samples and 3 pairs. But if it was 4, it would be 1, 2, 3. Yeah, would it be pairs?
I think it's 6 pairs since there's that many different pairs you could have.
Yeah.
What is it? There's 2 samples between every pair of samples. If 3 samples. I don't get it.
So for it's just asking when there's 3 samples, there's 3 pairs with 1 to 2, 1 to 3, and 2 to 3. And so when you list out the different ways, 1, 2, 3, and 4 could be together, there's 6 different ways. And so
Okay, so it's not so much like asking any new information as far as like, oh, in the chapter it talked about da 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 da, but it's just talking about each time that they've tried to pair up 1 through 4, paired into 4 separate, 4 different samples, so 1, 2, 3, 4 samples, how many times those can be matched together, correct?
yeah, exactly.
Okay. So we just put 6 in there then?
Yeah, that's all I said. Okay, number 8. The soccer shoes data has 6 groups, A, B, C, D, E, socks. These data can be found in the wiki. Load all the 6 samples into the quantitative inference procedure spreadsheet or perform an ANOVA test in SPSS and observe that the p-value is 0.0809. Remove the socks data. What is the p-value?
Okay. Remove socks. If you keep clicking on searching to the department, 6 groups A, B, C, D, E, and so. Instead, I type down in the wiki, load all 6 samples into the quantitative inference procedure spreadsheet. And or perform an ANOVA test on SPSS.
Where did you get the data from?
The soccer shoes.
Oh.
I have it open.
So then open that up and
So open it up. So my question is, are we just supposed to open up the ANOVA, like the comparative one, that one?
I don't think so. It's not taking
ANOVA. We don't have things left. Okay, so not that. So let's take that again. Something like that. Where did I go? That didn't happen.
Hey, Alyssa, how are you doing this?
So did you, okay. So first, you have to open it and then go, I just deleted, since they already gave us the p-value, we don't need it with the socks. And so I just deleted, I just like highlighted both the socks and all the number next to it and just like right click and then clear. And then I went to transform and then automatic recode. And then you have to type in, you do footwear and then, the arrow over, and then underneath it there's a box where you put in the new name, and I just typed in code in capital letters and then clicked add new name, and then, okay.
I don't think we had any. Can you pull up your share screen to see and walk us through it? Because I'm not quite sure what you mean about taking away the shoes.
I'm not sure if you guys will be able to see. Can you see it right now?
Yeah, we can see it right now.
Okay, so I went in to. So first off, I cleared the socks part.
Where's the socks part?
It used to be right here, and then I just deleted it.
Oh, we can't see that right now.
Oh. So can you see like that I'm in SPSS?
No.
Okay. Then I don't know as if I can. I might have to call you.
Because when we pull up the file, there's a row of footwear and then there's a row of accuracy and then a comments.
Yeah.
Is that what pulled up when you first did yours?
Yeah, it is. And so, there we go. So you have to go down to the bottom, like
very bottom?
Where it lists the socks.
Oh, there it is.
And then highlight everything that's the socks and then the accuracy, and just like right click and clear it.
So all the socks and their accuracy and clear it?
Because we're not using that in the ANOVA part.
Just a second. Can you just clear it? Is it just gonna? Yeah. Okay.
Click on the highlighter.
That's what I thought. And then now it's cleared.
Okay, so then you go into transform.
Oh,
and
transform.
Click on automatic recode.
Oh, there it is. Okay.
And then you click on the footwear and then do the arrow over so it's under in the variable new name box.
Uh-huh.
And then just do like I did code in capital letters like CODE, and then just clicked on underneath that add new name.
Okay.
And then click OK after you do that.
You just get the new value 1, 2, 3, 4, 5, 6, and then value label A, B, B, C, D, E.
I think so, yeah.
Okay.
And then after that, you do the ANOVA thing.
Oh, that's really good to get in there.
So, oh, okay.
And then we go to accuracy into the dependent list and then the code into the factor.
Yeah, so analyze ANOVA. Yeah, so the new footwear one is what you put in the factor.
Okay.
And then you click OK.
And then flip the questions. And so as the 6 groups, these guys can come with the we observe that the p-value is 0.0809. Remove this off to what is the p-value? P-value
3.309. Is that what we got, Elizabeth?
Yeah, that is.
Okay. Okay, got it.
Such a long process.
We said 0.309, right?
The p-value always goes up when
Yep.
only one group is removed compared to the p-value when all 6 samples are included.
When only one group is removed compared to the p-value when all 6. Yeah, didn't go. Wait, no, it did go up. Sorry, I thought that was another 0. Okay. What is the p-value you see for one group? You will need to compute an ANOVA for each possible option.
So like take the D
Okay.
and E and you do for each group possible?
So,
Oh man. I like
Yeah,
doing
so this is how I take it.
okay. So in order to do that, we would need to do the steps that we just did.
Yeah, so I guess if I
You do for A, B, C,
Yeah,
D,
since I
and
deleted
E.
all the ones for the socks, I think that either have to like reopen it or undo that or whatever, and then I guess just like copy and paste them into another so that you still have the information.
Oh, like into a new
Yeah.
stat sheet? Like into that.
Or into
and then we have to delete all of the E's, and then all of the C's,
Because
and
you
then
have
all
to
the
do
D's.
it for
Oh,
every group.
Okay, so it's gonna be super fun, guys.
Yeah, so fun.
Okay, let me see if I can do an undo motion and see if that brings any of them back. I think it did. Yeah, if you just click undo, it'll bring them all back. Oh, it only brought some of them back. No. Okay, I'm just gonna. Okay, me. Again. We'll just have to open it up. I'll open it up like 4 times, and then that way you don't have to open it up over and over again. I feel maybe because it's A, B, C, D, and E, so we have to do it 5 other times, including the socks, right?
Yeah.
Okay. So I have 4 of them open. Are you already doing A?
Me?
Yeah.
Yeah, I'll do A.
Okay, I'll
Without
do B
A.
real fast. Or without B, yeah. do on the website for the statistics right away. So it's statistics.byuimath.com. .byuimath.com.
Okay, so which ones are you guys doing?
And then we'll just go to data. I'm gonna do B and C.
Okay. And then Macy, which one are you doing?
Whatever one is left. I'm trying to figure out how to.
Okay.
You're doing A, Liza?
Yeah, and I'll do D.
Okay.
And you still said it was over the footwear, correct?
Yeah.
Right there. And then we're gonna do code.
How do you find? And how did you find the list of the?
So go to data, and you're probably gonna need to go to.
Shoes.
It should have the SPSS at the bottom. There you go. So go to the shoes, soccer shoes. There you go. So open up 2 of those if you can, and then you can do one with.
Which one am I doing?
I'm doing B and C.
Oh, so you're doing A?
Yeah, and D. So you just do E.
Okay, so go down to E, and you're gonna take out everything from E. No, so you're taking out E.
Oh,
Yeah.
I see.
Yeah. Okay, so that is E. This one.
There we go.
Okay, so once you've deleted everything for me, you're going to go to transform and go to automatic recode, and then you're going to take your footwear and move it over to the variable new name, and then put like code E, and it won't let you do a space. And then do the add new name, and do OK, and now you're going to do the analyze, and compare names to enable. And then that over, and then the code E is going to be the factor. And you're going to do options. And description means that. Okay. So I did for B, now I'm doing for C.
Okay.
Just the time. I got 1.0. I don't know if you guys.
What did you get for that one?
E, for, if I check out E, we got 0.05.
Okay.
And for B, without B, I got 0.052.
Okay.
What did you get for A?
I got 0.6, and then for E, I got 0.3, or like 0.03 and 0.06. So I think, and then did you also do C?
I'm almost done.
Okay.
I'll be done in about 2 seconds.
I think A might be the biggest one.
And so far means. Let's find out what C. Okay, for C, it's 0.554. So yeah, you said A was 0.6.
0.06.
Oh, 0.06.
Yeah.
And it was, what is the highest p-value you see when removing one group? So B was, let's think about it.
B was 0.052. Yeah. So okay, A is 0.06, B is 0.02, C is 0.54, D is 0.3, and then E is 0.05. So I think it's C that has the highest
Yeah.
Yeah.
p-value.
So it's 0.54, and then is it 0 after that?
No, 0.554.
Okay, 554. And then for number 9, then I think that's false because some of them are smaller than the p-value, that the original p-value.
Oh, yeah, the p-value always goes up when only one group is removed compared to the p-value when all the 6 samples are included. And our smallest number was 0.03, right? Or
Yeah.
no, 0.05. So yeah, so technically that would be false now.
Yeah.
Good catch. That is a good catch. I would not have found that. I've been like, done.
Okay, when
So-
all samples are used, what is the minimum standard deviation?
Oh, I still have that pulled up.
All
So
of them?
where
Everything. A,
Where do
B,
we
C, D, E, and socks.
do we find that?
Oh, like the smallest and the biggest standard deviation? Oh,
Yeah.
you know, when you do, okay, so do it again, but don't take anything out, and it'll give you a whole list.
Okay.
And then
Yeah.
they'll show you like all the standard deviation for all the groups.
Yeah.
And then you have the smallest one we have.
Oh, wait. Hold on. A second. I'm sure this one is the right one.
Stop.
I'm gonna make sure that would be the right one for the taking C out. Yeah. Okay.
So do we like recode it and then analyze and then do the ANOVA thing?
So,
Hold on.
just a second.
Okay.
I'm just making sure that it actually.
Wait, so
took
Alyssa,
out
let's
C.
go back to the question number of that. So what did you get when you took out A?
For what? I'm not-
Yeah, we're going to go back and talk about question 10. We're just trying to double check again.
I'm just double checking because when I was looking at the numbers, all the other ones, when I took like A out or B out or C out, it wasn't showing up in the actual data. And when I pull it up, it's still putting C in
Yeah.
here.
So when I took out E, my
Wonder-
p-value came up to be 0.50.
Oh, that's right. Just a second. It's been, let me try that one here. 0.448. It's still our higher one, but it's 0.448 for 10.
Okay, that's the answer.
I believe so.
Okay, now that we have that, I can go back and open up one that has everything in it
And then just go from there.
and do the exact same thing with just analyzing it, right?
Yeah,
Well, we wouldn't have a factor, would we? Okay. Nope, I wouldn't have a factor. So,
what did we do
just
earlier?
make
Today?
it. Do we just make it then?
Yeah.
Automatically code? Yeah. And then code or physics. Okay. Okay. So okay. Good. And goes in there, option.
What's the code 6 for?
For all 6 samples. So that if I'm opening it up, it's okay. And then the question was, when all 6 samples are used, what is the minimum, the small standard deviation? So for A, we have 5.230. B is 5.430. C is 5.216. D is 7.291. E is 5.569. SOX is 6.382. So
Would it be 5.2?
C, yeah, C again is 5.216.
So we just put in the 5.216. Is that what you're getting, Elizabeth?
Yeah, how do you guys find that?
Okay,
So open up a new soccer shoes,
Uh-huh.
CSS,
and
and then do your transform,
Uh-huh.
and then instead of having something removed, you're going to have A, B, C, D, E, and SOC still.
Uh-huh.
And then you're going to do the same thing where you rename it and not it 6 because it's all 6 factors.
So do you do the ANOVA?
Yes.
once you change your, do that first.
Once you change it so that you have your code 6 factor,
Yep.
and then you go into your analyze and your ANOVA, and it'll bring you up with a big one with A, B, C, D, E, and
Okay,
SOX.
I got it.
All that, yeah.
Awesome, thanks.
No problem.
And then the largest one is 7.
Yeah. So we found that because of that information, C would be the smallest at 5.216,
Uh-huh.
and D will be the biggest at 7.291.
All right, got that too. Okay, then the test for equal variances is satisfied for this data.
What is the test for
Let's see.
equal?
I would
The
say
largest, okay, so then we have to say the largest standard deviation is less than or equal to 2 times the smallest one.
yeah, that's true.
The largest is less than or equal to. Well, I still don't get that rule. How do I figure out that?
Less than or equal to 2 times the smallest. So as long as it's no more than, okay, so as long as it's no more than 2 times the smallest number, it's satisfied.
So 5.216 would be equal 10. So it should, as long as the largest is less than 0.432, then it should be equal. Because, okay, it makes perfect sense now. Oh my gosh. Does that make, okay, so 7.
So basically, as long as that the highest number is not more
And double the smallest number.
then it's satisfied. If it was, say, 11 or 12 or something like that, then it would not be satisfied.
Okay. So the test for, so 13 would be true.
Instruct the QQ plot for each. And you looking at the data.
Oh, is this the QQ plot?
Well, this is the means plot, so we gotta make a
QQ plot. So just go to analyze, yeah, QQ plot. If it's,
would I do code 6 or would I do the QQ?
because that's the one that has the data. The code 6 is just,
And then I just click OK.
okay. We'll find out. Yay! For instance,
Okay, so to make the QQ plot, do you have to like plug in each one separately?
oh,
No, we just did all 6 of them at the same time because it says construct a QQ plot for all for each of the 6 samples. Oh, okay. Start over. Thanks for catching that, Eliza.
Yep.
Darn you.
Okay, I'll do E.
I'll do B and C again.
This is so annoying, gosh.
Wait, so which ones are you guys doing?
Okay, just do the ones that you figure out the key
Okay.
value for. You do A and D, I do E, and then Abby's gonna do B and C.
You do E and socks.
Okay, yeah. I'll do E and C. Yeah, okay, so
Here's with B. And now here's my question. Would I put all of the kicking accuracy with B out, or would I put my code B in?
I don't think you need to code it.
Okay.
okay, so
So based on that, one follows
both of them.
B follows the line. Goodness. So much fun. Okay. And then C also follows the line.
So C and D both follow.
Yeah, C and D both follow. So B and C are approximately normal.
So that's that. Okay.
Okay, A and D are approximately normal.
Okay, yeah, socks and E is normal too, so then it would be normal.
Okay, so true.
Yeah.
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left?
Right. Because on here I remember writing down for F distribution in the reading percentage, it's right field, and the values of F are never negative, and the p-values for the area is right tail. We will never divide the area into two.
So it would be
Right.
right then.
Yep.
Do you agree, Alyssa?
Yep, I got it. I
Okay.
submitted it. We got 100%.
Good job.
Alrighty. Let's see.
Alright.
See if I can get this for the exam.
Alright. I'm gonna call you.
Okay. Yay, good job, guys.